Okay, here's the answer key for the slope fields assignment. The first page, we have the differential equation dy dx equals x plus 1, and we have to find the slope field for each of the 15 points indicated. Again, you can just make points, the coordinates, and plug them in, or if you want, you can always make a table where we have the value of x and then the value of dy dx. We don't need a column for y in this case because there are no y's in dy dx. So if x is 0, then y dy dx will be 1, and if x is 1, dy dx will be 2, so on and so forth. What's going to happen for this particular slope field is, as we said, when x is 0, dy dx is 1. So we will have slopes of 1 when x is 0. And when x is 0, that's the y-axis. When x is 1, the slope will be 2. So they'll be steeper. And then when x is 2, 2 plus 1 is 3. So dy dx will be 3. So those will be even steeper. When x is negative 1, then the derivative will be negative 1 plus 1, or 0. So we will have horizontal slopes when x is negative 1. And then finally, when x is negative 2, we add 1 to that and we get negative 1. So here is our slope field. So that's part A. That's now done. We've sketched the slope field. And we also need to draw the solution curve, which will pass through the point negative 1, 1. So we go to that point, back 1, up 1. So we are actually, I'll change colors here. We're going to go to blue. Okay, so we're going to start right there. Now our slope is telling us that we're horizontal at that moment, but it's leading us to positive 1 slopes in both to the right and negative 1 slopes to the left, and we're kind of done to the left, so now we're just going to keep continuing. And as we approach x equals 1, now things are getting steeper, and so basically our solution curve is something like that. Alright, moving on to the second problem. We have dy dx is equal to 1 minus y, so we're now looking at only y values in our slope, so we can make a table. We have y and dy dx, and when y is equal to 0, well, 1 minus y is 1, so the slope when y is 0 will be dy dx will be 1. Alright, so the line y equals 0, that's our x-axis, and the slope is always going to be 1. Alright, so 1 here, 2, 3, 4, 5. Now we can make y equal to 1. When y is 1, we have 1 minus 1, or 0 for dy dx, so we will have horizontal line segments on the line y equals 1. Now we get to the line y equals 2. When y is 2, 1 minus 2 is negative 1, so we're going to have negative 1 slopes for each of those 5 points. Okay, in regards to the solution curve, our initial condition is negative 1, 2, so back 1, up 2, that's this point right here. And we can see that we have a negative 1 slope, which is leading us down this way. And as we get here, we flatten out. Now we cannot get down here because one horizontal slope leads us to the next horizontal slope. So this is going to continue onward forever, whereas this one will steepen up as we move off the graph. This is a derivative which only involves the original function, which means it's going to be exponential. And you can see the exponential growth here, in this case the exponential decay, since we have the negative sign. Okay, for the next couple, going to just move this down. There we go. Okay, I've already got the slope fields written in because it takes a little bit longer to get these done. But again, just to give you a general idea, we have an x column, a y column, and a dy dx column. All right, and we start off, say, at this point right here. This is the point x is 0 and y is 2. X is 0, y is 2. So dy dx, we plug in 0 for x and 2 for y. So we'll have 2 times 0 over 2, which is 0, which is why you see a horizontal slope right here. In fact, the entire y-axis, with the exception of the origin, will have a horizontal slope because that's when x is 0. On the x-axis, now y is equal to 0, and when that's the case, that means that we are dividing by 0, which does not exist, which is why there are no slopes on the y-axis. For all the other points, you see we have negative slopes to the left, we have positive slopes to the right. And if we want to sketch our solution curve, we are going to the point over 1, up 2. Over 1, up 2 is this point right here, and that's going to lead us to a horizontal slope, which is then going to lead us back in this manner, and we're doing that to the right. So we're looking at some kind of solution curve like this. Okay, regarding the last problem, we have dy dx is equal to y times x minus 1. So if we look at this, when x is 1, we're always going to get 0 here. So when x is 1, it doesn't matter what y will be, dy dx will be equal to 0. Along the same lines, when y is 0, it doesn't matter what x is, because 0 times anything is 0. So again, when y is 0, no matter what x is, we're going to get 0, which is why you see horizontal slopes in these spots. Alright, now when x is equal to 2, then we have, and y is 1, alright, then we end up with 2 minus 1, or 1 times 1, so we have these slopes right here. The last two I just want to do for you are what happens when x, let's see if I can make another chart here, x, y, dy dx. Okay, what happens when x is 0 and y is 1? When x is 0 and y is 1, we have negative 1 times 1, or negative 1. So we got that slope right there. And then when x is 0 and y is 2, we're going to again have 0 minus 1, or negative 1 times 2. So that's a slope of negative 2. So now we're looking at something like that. So we have some very steep negative slopes, especially up here. I think that one's negative 6 there. Okay, and then they slowly mellow out before turning positive. Now, finally, we have to sketch the solution curve that passes through the point over 2 up 0. So over 2 up 0 is that point right there. So where does this slope lead us? It leads us to that point, which leads us to that point, which leads us all the way across, which means we actually don't even touch any of the slopes above or below the y-axis.